Hello everyone, in this video we are going to discuss this JEE Main 2026 20th January morning shift problem where this trigonometry question was asked. Okay, and if you see in internet there is a common and standard approach to solve this problem, but in this video I am going to discuss the approach on how to solve this problem without using trigonometry. Indirectly, in the sense I'm going to use only 10th standard trigonometry, like dealing with standard values, etc. That's it. Okay, and with that standard case we are going to solve this problem. Okay, now the question says if tan of a minus b by tan a plus sine square c by sine square a is equal to 1, where a b c belongs to first quadrant apart from 0 and 90 degrees, then they are asking relationship between tan a, tan b and tan c. Okay, now I'm going to use the approach of without using trigonometry. Now let's see how we can do. Now if I write the equation given in the question, it is going to be before, let me not write that. Let me assume this as A and this as B. Now we know that A plus B should be 1. Okay, and since the angles are in first quadrant, we need not worry about the plus minus. Now here I'm going to assume standard angles because they have not specified anything apart from this condition. So you can take any angle and prove which option will be correct. Okay, so if I take angles like 0 degree, 30 degree, or if we write in radians, then if I write 0, pi by 6, pi by 4, then pi by 3 and pi by 2, if I write in this form, then one thing is clear that if sine square c by sine square a is b, okay, sine square c by sine square a is b, then this implies that sine c by sine a is root b, and here we need not consider plus minus because the angles are in first quadrant. So here it's going to be root b. Now if you see the sine values of 0, 30, 45, 60 and 90 are something which is quite easy to deal with. So that's why we are assuming these 5 angles. Okay, they are quite easy to deal with. Okay, now if you see sine 0 will be 0 and sine pi by 6 will be half, sine pi by 4 will be 1 by root 2 and sine pi by 3 will be root 3 by 2, correct, and sine pi by 2 will be 1, correct. Now if you see there is a ratio of sines, and if this is equal to root b, then one possible case is where your b can be maybe, let's say, 2, right. Maybe your b can be 1 by root 2, right? 1 by root 2 can be a possible case, right? 1 by root 2 can be a possible case, 1 by root 2, or even 1 by 2 is also possible. Okay, how 1 by root 2? If you divide 1 by 2, which is sine 30, by 1 by root 2, which is sine 45, then you will get something like root 2 by 2, correct, and this is going to be again 1 by root 2. So in this way also you can conclude that root b can be root of 1 by 2, or root b can be 2 as well. How? If you divide sine 30 by sine 90. Okay, but the technical problem is that we cannot take sine a as 1 because there is a tan a over here, and if you take a as 90, this will be infinity, which is not defined, so we are not going to take that one. And even if you take 1 by infinity as 0, then this will be 0 overall. But sine square c, since sine c is half and sine a is 1, so sine square c will be 1 by 4, and that will not be equal to 1. So that's why we are not going to take tan a as 90. So indirectly half is rejected, and for our case we are going to take sine c by sine a as 1 by root 2. So this implies that sine c should be, now here also you can take sine c as 45 and sine a as c as 45 and a as 90. Like if you divide sin pi by 4 by sin pi by 2, you can do the same thing, but again if you take as 90, here you will get a problem. So that's why, and even if you substitute sin square 45, you will get 1 by 2, that will also not be 1. So that's why we must not take sin c as 1 by root 2 and sin a as 1. So the only left option for our case is, for our plan is, where we can take sin c as half, which implies c is 30 degrees or pi by 6, and your sin a will be 1 by root 2, right? And this implies a is 45 or pi by 4. Okay, and they're asking the relationship between tan of angle, so we can take tan directly as well. So tan c should be 1 by root 3, and tan pi by 4 should be 1. Okay, or tan a should be 1. Now let us see how we can find out b, capital B. Now if you see, sin c by sin a is 1 by root 2, which implies sin square c by sin square a is 1 by 2, and if b is 1 by 2, then a should also be 1 by 2. So this implies tan of a minus b, a is pi by 4, so pi by 4 minus b should be equal to a times tan a, and a is your half, and tan a, what is the tan a? Tan a is 1, so it is going to be half. Okay, now what we are going to do is that we are going to expand this one. Okay, we are going to expand this one, and if you expand this one, then what will happen? You will get something like 1 minus tan b, 1 minus tan b, let me assume this as x, by 1 plus x, and this is equal to 1 by 2. This implies 2 minus 2x is equal to 1 plus x, and this implies 1 is equal to 3x, and this implies tan b, right? Tan b is equal to 1 by 3. Okay, this implies tan b is 1 by 3. Any mistake? Any mistake or what? So tan a is 1, tan c is 1 by root 3, and your tan b turns out to be 1 by 3, right? Tan b turns out to be 1 by 3, and tan c turns out to be 1 by root 3, and tan a turns out to be 1. Okay, now if you see very carefully that wait, let me remove this page, is unnecessary disturbing. Yeah, now if you see tan a, okay, tan a is 1, tan c is 1 by root 3, and tan b is 1 by 3. Now what is clear is that the common ratio is 1 by root 3, correct? If you multiply 1 into 1 by root 3, you will get 1 by root 3, and if you multiply one more 1 by root 3, you will get 1 by 3. So one thing is clear, that tan a comma tan c comma tan b, they are in GP. So that's why the final answer for this question is option B. And C, we are able to complete in 8 minutes itself. Okay, 9 minutes because of explanation. Okay, if I'm not explaining, then maybe I could have covered in within 2 minutes itself, okay, without using any kind of trigonometry. But this is not the true way to learn. This is just an exam shortcut I've explained. Okay, and so see you soon in the next video. Until then, all the best for your upcoming exam preparation. Thank you.